The rest of chapter 8, we're going to do something a little different. Instead of multiplying things out, we're going to do the opposite, which is called factoring. So by the end of this lesson, you should be able to factor a monomial from a polynomial, and then be able to factor polynomials with 4 terms. So this word factoring reverses multiplication. So before, you did problems that looked like this, and you would have to distribute this 3 to both of those things. You'd multiply it, and you'd end up with this. Same thing with this stuff down here. You'd distribute it, you'd combine what you could, and you'd end up with something that didn't have multiplication as your answer. So what we're going to do is we're going to take something like this, and we're going to factor something out. And in order to factor something out, it has to be something that they have in common. So factoring a common term means that we're going to break it down into its possible products. So you've done this before with plain old numbers. So if I give you a number like 12, you can break this number down into its products, which means multiplication. So any two numbers that multiply to make 12, like 2 and 6, 2 is as broken down as possible, but 6 can be broken down into 2 and 3. So this number 12 is the same thing as 2 times 2 times 3. Now if I give you a number like 15, we can do the same thing. We can break this down. This breaks down into 5 and 3, and that's as simple as it goes. So if I look at the numbers 12 and 13, the factor that they have in common is a 3. So that's what we're going to be looking at with all of these terms that we have. What do they have in common? So the first couple of things that we're going to do are going to be very tedious and a lot of work. And then hopefully once you catch that, you'll be able to do it without as much work. So right now, these problems, all it wants you to do is find the GCF, or the greatest common factor. So what do these things have in common? So what we're going to do is we're going to take each one of these, and we're going to break it up into its terms. So 5 is a prime number. That doesn't break down at all, but I know v to the 5th means 5 v's, all being multiplied together here. And then I'm going to take the other one, 10v cubed. I'm going to break that down. 10 can be broken up into 2 and 5, and then we have 3 v's, all multiplied together. So the thing that they have in common is they both have a 5. Here's a v that they both have in common. Here's another v they both have in common, and one more. So the GCF of these two terms is 5v cubed. That's what they have in common. These two v's out here, this doesn't have, and this 2, this doesn't have. So we can do the same thing with the next one. Take 3t squared and break that up. That's 3 times t times t. 18, let's see, that can be broken down into 9 and 2, and we know 9 is really 3 times 3. So the only thing that these guys have in common is 1, 3. So the GCF is 3. Now hopefully once you do a couple of these, you're getting a little better at them. So if we just look at the numbers here, 4, 2, and 6. The biggest number that goes into all of them is 2. This guy has 3 b's, this guy has 2 b's, and this guy only has 1. So the most that they have in common is just one of them, and that's your GCF. Now if you need to write all this out, go ahead and do so, but for the rest of these, I am not going to. Actually, for the first one, I am here, and then I won't after that. So these directions are a little different. It says to use the GCF to factor each polynomial. So we first need to find out what the GCF is, and then we need to unmultiply that by everything in here. So let's take a look at what we have. 8x squared. This can be broken down into 2 times 2 times 2 times x times x. And 12x can be broken down into 2 times 2 times 3 times x. So to see what they have in common, we have these two groups of 2 and one group of x. So the GCF here is 4x. And now the last directions, that's all we had to do. This time what we're going to do is we're going to undistribute 4x and see what's left over. So for our first term, if I take out the 4x, that means that I take out this 2, and this x. What I have left is 2x here. And for the 12x, I have a 3. Now remember, this was a negative 12x, so I want to subtract the 3 here. When you get done with factoring, you should be able to check your work by distributing this back out. So if I multiply those, I get 8x squared, which is good because that's what I started with, minus 12x, which is good because that's what I started with. So this right here is the factored form of what I started with. Now once you can find the GCF, it's pretty easy to do the rest of it. It's the whole GCF thing that gets people stuck. So if we look at the next one, just take a look at your numbers first, 5 and 10. The biggest number that they have in common is 5, so I'm going to take that out. This guy has 3 D's, and this guy only has 1, so I can only take 1 out. And then ask yourself, what would be left, or what would I need to multiply 5D by to give me 5D cubed? Well, I already have the 5, and I'm missing 2 D's, so it needs to be D squared here. And to multiply 5D by something to get 10D, I would have to just multiply it by 2 because I have all the D's there. I want you guys to try this one on your own. So the second half of this is about factoring by grouping. And for this, we are going to factor 2 different things by grouping them together. We're going to use the distributive property again, but what we're going to do is I'm going to give you something with 1, 2, 3, 4 terms. And at first, we're just going to look at the first 2 terms and forget that these guys even exist. We're going to find the GCF, and we're going to figure out what's left over. And then we're going to come over here and we're going to do the same thing. We're going to forget that this exists, find the GCF of these 2 guys, and factor it out. Now, if you do this right, these 2 things should be the same. And then what we're going to do is we're going to factor that out and see what's left over, which is the y squared plus 4. To factor by grouping, you should always look for a common binomial factor of 2 pairs of terms. So in order to factor these, the first thing you should always look for is a GCF. It doesn't matter what we are factoring, look to see if they have anything in common. So let's look at our numbers first, 5, 20, 6, and 24. So the 5 and the 6 are going to cut us off right there because those don't have anything in common. It doesn't matter if everything else does. And then the T's, this guy is 4, this guy is 3, this guy is 1, this guy doesn't have any. So there's no greatest common factor here that I can take out. So then your next step is to group them together. So let's just look at these guys. What did these 2 have in common? Well, they both have a 5. And then this guy has 4 T's and this guy has 3. So that means I can take out 3 of them because they have them in common. So now to multiply 5t cubed by something and get 5t to the 4th, I just need 1 more t. And to go from 5t cubed to 20t cubed, I need to multiply it by 4. And now we're going to forget about this, and we're just going to look at these 2 things right here. So 6t and 24, they have a positive 6 in common. And to go from 6 to 6t, I got to multiply by t. And to go from 6 to 24, I got to multiply by 4. So we can see that we got the same thing here in the middle. That's our check. So t plus 4, I'm going to factor out. And then what's left over? 5t cubed plus 6. And this right here is the factored version of that. And you can check this because you should know how to distribute this back out. You would have to double distribute, but it should simplify to what you started with. We can do the same thing with this one, but I'm going to leave this one for you to do because this next one is a little different. So like I said before, the first thing you should do is look for a greatest common factor. So what I always do to kind of make this simple is I always find the smallest number. So in this case, my smallest number is 6. And then I think about his factors. His factors are 2 and 3. So does 2 or 3 go into the rest of these numbers? Well, 2 doesn't go into 45, so I can forget about that one. But 3 does. 3 also goes into 9. 3 goes into 30. So that's a common factor that I can take out. I can take out a 3. And then if we look at our letters, everybody has at least one M. So that is a GCF that I can pull out. So before I do any factoring by grouping, I'm going to make what's inside of this a little simpler. So to get 3 from 45, remember we're going backwards. We're trying to ask ourselves, like, what do you have to multiply by 3 to get 45? So if you need to, if you don't know it off the top of your head, divide it and you get 15. I need 3 more M's. This will give me negative 3 M squared, 10 M, and then minus 2. So because I have 4 terms here, I need to check to see if I can factor by grouping. So that's when we take just these 2 things right here, and we're going to forget that that 3M's on the outside. Now if we just look at those 2 things, the 15 and 3, they have a 3 in common, and they have 2 M's in common. And when I factor that out, I'm left with 5M minus 1, and then do the same thing over here. 10M and negative 2 have a 2 in common. If I take a 2 out of 10M, I'm getting 5M. And then to go from 2 to negative 2, I have to multiply by negative 1. So just like before, we know we did it correct because this stuff right here is the same, the 5M minus 1. And then I have 3M squared plus 2 left over. And now remember, this was just the stuff that was inside of these parentheses. So before I box this up and make it my answer, I have to remember that I pulled out a 3M from the front of this. So this right here is my answer. So you have the 2 that I left you to do, and these 2 right here. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.